Yeah, hello guys. We are here today we want to look something about homogeneous equation with constant coefficient. Homogeneous equation with constant coefficient. Okay, so homogeneous equation in the sense that the particular side has been equal to zero or has been equated to zero, and you can see that this is the form of homogeneity, but despite it's a second order, it is what a second order homogeneous constant coefficient. So constant in the sense that the A2 and the A1, A0 are all constant. It can be the A1, A2, A0 can be um, any integer. So it can be any integer. So say my A1 can be 2, it can be 4, it can be any integer, it can be 3, my A2 to the same thing. So quickly, I know that my constant A2, A1, A0 is constant, so it can be any integer. But remember, not a function, it's an integer. Okay, so these are three main cases we consider in homogeneous equation with constant coefficient. Okay, so the first case is that the root is rare and distinct. So if the root is rare and distinct, we always find the root from the general form of homogeneous equation with constant coefficient. So a question will be given, then you solve it. So after this lesson, or maybe there will be some question ahead, so you understand what you are trying to mean. Okay, so if the root is rare and distinct, then my b squared minus 4ac should be greater than 0. Hence, we will have it in the form y equals c1 e exponent r1 x plus c2 e exponent r2 x. Okay, so my y equals this c1 e exponent r1 x plus c2 e exponent rx is more or less the general form. Okay, it's more or less the general form. It's a general form. So when we have equation and it is rare and distinct, then this is how we will write it in general form. Okay, where my R1 is not equal to R2. Okay, another case is that if the root is rare and identical, then or if b squared minus 4ac is equal to 0, then my general solution will be in the form y equals c1 some particular constant times e exponent r plus c2 x e exponent r, where my r1 is equal to r2. Okay, and lastly, the third case we should consider in a constant homogeneous equation or a constant coefficient with homogeneity. If the root is complex conjugate, in the sense that if b squared minus 4ac is less than 0, then this is how my general solution is going to be. The general solution is going to be y equals e exponent alpha x multiply. Pardon, please forgive me. This is alpha, not a. It's alpha. Sorry, this is alpha, not a. Okay, so bracket open multiplying c1 cos beta x plus sine beta x, where my r is equal to my alpha plus or minus beta. Okay, so let's quickly solve examples so that we understand what you are trying to mean. Okay, so this is the question on board. You should solve the differential equation y prime plus 2y prime plus y equals 0. So solution. So all that we are trying to do is that for homogeneous constant coefficient, we make this substitution. You make your y substitution, y to be equal to e exponent rx. Then this is more or less a function, so we don't know the function, so we assume that this is my solution. So, and we've learned that for a particular solution to satisfy, then that solution must be equal to 0 when we put it into the original equation. Then that solution must be what? 0. Okay, so we first differentiate my function, some function of this. So when we differentiate this, you know that we are going to get the r. We are differentiating y with respect to r. So you know how to differentiate an exponential function. We maintain the e exponent rx, then we differentiate the exponent. When we differentiate the exponent rx, we are getting r, then we multiply. Then after that, we differentiate the first one again to get the second derivative, which is, you know that we maintain the e exponent rx, then more or less we also differentiate the exponent rx. So we differentiate the exponent rx, we are going to get r multiplying r here, so giving us r square e exponent rx. Okay, then after that we try to substitute the answer. So wherever we see y prime, we make a substitution from the original question or the original equation that was given. So wherever I see my y prime, I will substitute re exponent rx from this equation. So upon doing that, we obtain r square e exponent rx plus 2 re rx plus e exponent rx equals 0. Then we try to factorize e exponent rx out. So we are leaving this equation. This is more or less a quadratic equation. So we solve this. This equation is called the characteristic equation. So upon solving this characteristic equation, we know that we are going to get a solution r equals -1, which is repeating. So I did it r equals -1 comma and -1 again. So this shows the -1 is repeating. So we get to our cases where the r1 is equal to r2. I mean, from our case 2, if the root is rare and identical, this is how the general solution is going to be. So we just write our general solution at that place. So this is my general solution because the root is identical, -1 -1. So this is how the general solution is going to be. So wherever you see I will substitute -1, but in order to avoid repetition, we add x to the second constant. So my first constant e exponent r, which is -x plus c2. Then because when we eliminate x, it is more or less going to be a repetition of this. So the idea is that we will bring x to avoid repetition in the general form. Thank you. Please help share the video, comment, like, please. I hope you enjoyed it.